With thermodynamics, there's three variables that you're going to see a lot of: delta H, delta S, and delta G. Delta H is known as the enthalpy or the heat. Delta S is the entropy. A lot of people mix up the terms enthalpy and entropy. An easy way to remember it is heat has the H. Another term for entropy is chaos or disorder. Delta G is known as the Gibbs free energy. It can be called the spontaneity, which you can see why there's a confusion between delta S and spontaneity. A better term than spontaneity is thermodynamic favorability. It's only better in that it's more descriptive. It's definitely not better in length. Okay. Sign conventions that you need to know for each. Delta H, you should know already that a negative delta H is exothermic and a positive delta H is endothermic. You've used heat when doing products minus reactants, etc. You also looked at energy profiles, like for an exothermic reaction, it looks something like that. Entropy, a positive delta S is an increase in disorder. Which obviously the converse then is a negative delta S is an increase in disorder. One way I've heard people remember that S is disorder is it's the, I can't say the word, that's when I'm recording it, the shootiness of it. Delta G is a spontaneity. A negative delta G means the reaction is favored. A positive delta G means not favored. Delta G can change with temperature. Sometimes a reaction is not favored at room temperature, but if we heat it up, it is favored, or it's not favored at room temperature, but if we cool it down, it is favored. So delta G naught means at 25 degrees Celsius. Okay, predicting the sign of delta S. To decide whether it's a positive delta S or negative delta S. Generally, the entropy, gases are the most disordered, which is more disordered than aqueous, which is more disordered than liquid, and the most ordered is a solid. So if I looked at a reaction, for example, this, CO3 solid becomes CaO solid plus CO2 gas, and I asked you whether it was a positive delta S or a negative delta S, I'm comparing the two sides of the reaction. Over the course of the reaction, we form a gas molecule, or a lot of them really. And so our products are more disordered than the solid we started with. We've created chaos. And so since we've created chaos, we get a positive delta S. You might see something like this. I want to do that differently. If I look at a precipitation reaction where I'm forming a solid from aqueous species that are, so I have things that are swimming around in solution in a lot of motion, and then they crystallize into a solid form. This would have a decrease in disorder. So you look at phase primarily. And gas is definitely the most important in determining spontaneity because gas molecules are the most chaotic of the different kinds. If you have a situation like this, two, 4, 5, 6, where everything's a gas, then you want to look at moles of gas. So for this one, on the left-hand side, I have 4 moles of gas. On the right-hand side, I have 4 moles of gas. This one you would not be able to predict because the moles of gas are the same. So without having more information, you'd have to actually calculate instead of predict it. But if I had this, and now I added my moles of gas. I have 4 moles of gas here. I have 2 moles of gas here. So since this was a decrease, I would give it a negative delta S value.